Hello, everyone, and welcome to the ninth episode of the Espresso series. This is Aakanksha, and I'm a data scientist in AI Ops team at AI Center of Excellence at Red Hat. And I'm going to talk about 10 principles of the data science code review. Code reviews are a common practice in the software engineering field and have been for some time. They provide developers with a well-defined approach to sharing knowledge, ensuring exposure to new ideas and technologies, enforcing quality assurance of code and standards for the engineering processes across both the code base and the team itself. As the members of AI Center of Excellence in the Office of CTO, we believe that having a well-defined approach for how to do the same thing with data science and machine learning code is critical. Although code is code and we approach data science work as a subset of software engineering, there are some data science specific challenges associated with the code review process that should be addressed. So here are 10 principles that we use in our team to review data science work. So what is a code review? Essentially, it is a collaborative effort of the team and other people who are invested in your code, looking over your code and providing valuable feedback, improvements, and asking questions. It's not clearly people watching you code, but is a process that is such. While we are working on a project with the team, we have well-defined process of adding code to the upstream, starting from creating a commit on your fork and adding a PR upstream, then getting the pull request reviewed. Well, that brings us to the next question. Why do we need to review the code? If you merge the code without reviewing, there are chances of this happening. In order to avoid breaking of code and for better understanding of the code by all teammates, it's very essential to review the pull request meticulously. Let's take a look at the 10 principles of the data science code review we at AIOps follow. Understand the context. Make sure you read the pull request description and any linked issues so you know the data scientist's goal. This will help you provide an appropriate level of feedback and focus on the meaningful changes. Rich differences. Use tools like NB Review or NB Dime whenever possible to review the notebooks. These kinds of tools help you zero in on the notebook, changes that actually matter. Is it coherent? Notebooks generally contain a mix of code, markdown, and plots. Do these elements even reference each other correctly? Is the evaluation metric being used here suitable for the ML algorithm? If you don't understand something or are curious about why a certain approach was implemented, just ask and get some clarification. In order to ensure that the results are proper, we first need to make sure that we are selecting the most useful features to train on among existing features and combining existing features to create new, more useful features that can have higher importance in the model. There could be cases where our model results in underfitting or overfitting. Both the situations could lead into incoherent results. Check the math. Machine learning code can run successfully while still being wrong and not achieving the appropriate task. Read the notebook thoroughly and try to look for any little mathematical errors in the code with reference to the PR's stated goal. Does it solve the right problem? Make sure the goals of the PR or notebook are met. The key takeaways should be highlighted and the data scientist's interpretation of any statistical or any experimental results are included. Introduce new libraries or technologies. When working on a data science project, there might be times when you are aware of a library or a technology that can address the problem in a more efficient way. In such scenarios, you should suggest the approach in the code review. Is it reproducible? Are all of the dependencies used to run the code appropriately tracked using a pip file or requirements file? If you're unsure about any outputs or results, clone the pull request in your environment and run it yourself. It should run from top to bottom without error and should generate the exact same outputs as presented in the pull request. Understand the visualizations. When reviewing a PR that includes visualizations, make sure to check for the proper labeling of the axes and the ticks. All the values mentioned should be clear and have an explanation by the end of each graph. Hard-coded paths and credentials. Sometimes developers use hard-coded credentials, secrets, and even data directories for quick tests and easy access when needed, and then forget to remove them before publishing them to GitHub. When reviewing a code, make sure to check for any credentials, secrets, or paths, as this practice poses a significant security risk that can allow attackers to bypass the authentication mechanisms. Always ensure that the data management is handled properly and there are no hard-coded directories in the code. Evaluate the output. Finally, everything looks right, but our validation results are way worse than expected. Sometimes the simplest things can go wrong, like overfitting, poorly tuned hyperparameters, or maybe an inappropriate distance metrics being used. Make sure to double check even the smallest details when you're reviewing an ML code. Well, I hope these principles help you all data scientists review your code efficiently. Please feel free to ask questions and leave feedback in the comments. See you in the next episode of the Espresso series.